Hi there guys. In today's video, I want to show you how to solve quadratic inequalities. Okay, so first of all, quadratic refers to when you have an inequality with an x squared in the expression. And typically when x squared is the highest power in that expression. Then inequalities is simply when you either have greater than or less than. So for example, if a function is either greater than 0 or if a function is less than 0. This fx simply being the expression that is in question. Now, if it's greater than 0, then we have a look at these arms that are above the x-axis. Remember, the x-axis is where y is 0. So above the x-axis would be these arms and these x values. You look at the x values that's linked to these arms. Okay, so you need to know what your x-intercepts is. I wrote R1 and R2 as my two x-intercepts. So whenever something is greater than 0, this is how you write it. You say x less than whatever that x-intercept is, and x greater than whatever this x-intercept is. So in this case, x is less than R1 and x is greater than R2. It's two separate inequalities, two separate portions of the graph that is greater than 0, and that's why I write it like this. If f of x is less than 0, we are talking about this part that is under the x-axis, where y is 0, and so therefore less than 0 would be all these x values. That speaks about this part of the graph that is less than 0. And we write that as all the x values greater than R1, but also less than R2. So this is how we write it, as a unified inequality. Just one inequality with a lower boundary and an upper boundary. Now, let's have a look at an example of a quadratic inequality. So here's your first example. We have a quadratic inequality, and to solve this, we will first factorize to find our critical values. So, the factors of 10 is 5 and 2. Negative 5 and positive 2, once we add them, gives us the middle term of negative 3. So, the critical values in this case, I'll put CV for critical values. X is equal to 5 or x is equal to negative 2. Okay, so in that sketch that we had earlier, we noted that this was a quadratic inequality and that the critical values is, I'm going to write the smaller one on this side, so the negative 2, and the bigger one on this side, the 5. When we write our answer, our final answer for this as an inequality, we need to remember that since this is less than 0, it's going to be the unified inequality with a lower boundary and an upper boundary. So I write the answer to this like this. All the x values greater than negative 2, but less than 5. And that's how we solve this inequality. This is our second example. Here we have x being multiplied by the bracket 1 minus x, and this is less than negative 6. We need to solve x for this quadratic inequality. When we multiply out, we get x minus x squared, and this is less than negative 6. Okay, so it's important that I keep my x squared term positive. In order to do that, I could either divide by a negative, or I could just take it to the other side, which then changes this into a positive and that a negative, and we still have the minus 6 chilling on this side. I'm now going to factorize to find my critical values. So, the factors of 6 to give me the negative 1 would be negative 3 and positive 2. Okay, therefore, my critical values is where x is equal to 3 or where x is equal to negative 2. Now let's draw a neat sketch to answer this fully. I'll just do it on the side here. So, greater than 0, we said is the two arms that is above the x-axis. Okay, so we'll be writing it as two separate inequalities. We'll say, final answer, all the x values less than the smallest one, so less than -2, and all the x values greater than the bigger one, 3. So, less than -2, greater than 3, referring to these arms which is above the x-axis.